One more thing I want to explain about the multiplication command, that how the compiler knows that this is a 8 cross 8 multiplication or 16 cross 16 multiplication, because actually this will depend upon the size of operand that is being passed after the multiplication command. If you pass the 8-bit register, your compiler will assume that it's an 8-bit multiplication, and it will multiply 8-bit of that register which is being placed after the multiplication command with the 8-bit of AL. And if there is a value of 16-bit register after the multiplication command, that will automatically get the first operand from AX register, and it will assume that there is a multiplication of 16 cross 16 bit. So basically compiler know about the size of multiplication by the register that is being passed after the multiplication command in the syntax. Now I move forward to the division command. In division command is again such a command that it requires only one operand, and another operand will be gathered from AX register automatically. For example, now there are options of two type of division. One is if you want to divide a 16-bit number by 8-bit number, and there is another option that you can divide a 32-bit number by 16-bit number. So in first case I'll talking about 16 by 8-bit division. In that case you need to place your first value that is being divided by the second value. The first value that is stored in AX register, the second will be stored in any other general purpose register, and you need to apply the division command, and the operand of division command decide that it is a 16 by 8 division or 32 by 16 division. So in that case, if you consider these three statements, the first value will be stored in AX register, and you are bound to store that value in AX register. After execution DIV space BH, the compiler automatically finds that first value should be in AX register. So basically the division will be in such form that you will be placing 2, 3, 3, 4, and you will be dividing with 1, 6, 7. Here I am taking it as an hexadecimal value, but actually this division will be performed, I am taking as a decimal example, but actually this division will be performed in hexadecimal, because you know that you will be storing the answers in form of hexadecimal when we move value to any register. So now there will be a quotient, there can be a remainder. So the quotient will be stored in AL, and the remainder will be stored in AH. After execution of this command, there will be two answers. One is of the quotient and second one is of the remainder. Your AL will be containing the quotient part, and your AH will be containing the remainder part. Now what about the 32 by 16 bit division? In that case you need to place your values in AX and DX register. You need to place your values in AX and DX register. Your least significant 16 bit will be stored in AX register, whereas your most significant 16 bit will be stored in DX register. Here you can see the example. If I want to divide 39872H with 4, 5, 6, 6, 7, 8. So this is a 32-bit value. You need to store first 16-bit in AX and other 16-bit in DX. Then you will be using command DIVBX. So a compiler knows that there is a division of 32 by 16 bit. So automatically compiler gets 32 bit from AX and DX register in such a way that first 16 bit will be stored in AX and second 16 bit will be, or most significant 16 bit will be stored in DX. Now again, after execution there will be a quotient as well as remainder. Now after execution, this statement, your quotient will be found in AX register and your remainder will be found in DX register. These multiplication division commands are a bit confusing. You need to basically run these example on the emulator, and you need to verify the output step by step. Basically the tricky part is to memorize, to learn that in case of 8-bit cross 8-bit multiplication or 16-bit cross 16-bit multiplication, where we need to place the values. Similarly, in division, we need to something called memorize the register where we will be placing the values, and from where or from which register we get the answers of remainder and quotient. So basically, you need to recall these register and commands in such a way that you know that in case of 16-bit division or in case of 8-bit division, we need to place the values, and from where we need to get the quotient and remainders. So these are the instructions, these are the arithmetic instructions which we need to use in that lab. I hope this is clear. If there are any confusion, I will also be sharing these slides with you